Welcome. In this video lecture, I am going to talk about stochastic inventory models. More specifically, we are going to talk about the single item stochastic inventory models. So, I am going to cover in this part what are the stochastic inventory models we will discuss, and then we will try to define what is the safety stock, and then what are the service level measures, and then we will discuss how we can calculate the safety stock level when we have the empirical data, or you can say the based on the empirical distribution. So in the next part we will talk about based on the statistical distributions as well as periodic review models based, and the next one is single stage stochastic inventory models based on the chance constraint, and then how we can convert it into the deterministic form. But in this part, we are going to cover this one up to the empirical distribution. So first of all, what are the single item stochastic inventory models we are going to cover? So we will first cover based on the continuous review model policies, and then we will talk about the periodic review. So as we know that based on the continuous review, that means we are monitoring the quantity level of every stock keeping unit. Okay, and then we are talking about that whether the demand is variable and the lead time is constant, whether the demand is constant but the lead time is variable form, and if both are in a variable form. Same is the case for the periodic review. But right now we will talk about in a empirical distribution perspective as well as in the statistical distribution perspective, all these models. Okay, but first of all, let's discuss what is a safety stock. So how we can define safety stock or a buffer stock, that is basically on hand inventory during the lead time, which we can calculate the average demand, let's say per day, multiply by the lead time in days, plus the buffer, or you can say plus the safety stock. As we can see from this particular diagram, okay, if this is the reorder point, so we are saying that this is the time period that we are saying the demand during the lead time, because this was the lead time. We have placed the order over here and we are saying that we are going to receive this order over here. So this means the demand during this lead time, and then after that we have to calculate how much buffer we should have or how much safety stock we should have. Okay, so the reason behind we are having this safety stock, that is due to the uncertainty in the lead time, as we have discussed earlier, that there is a stochastic lead time, okay, or the variable lead time, or we have the probabilistic demand, right? That is the demand is in a varying form. So that's why we keep the safety stock in order to meet those uncertainties. So as well as the safety stock also help us to reduce the probability of the stockouts, or you can say the back order. So stockout means the shortages of the inventory of that particular SKUs. Now we are talking about how we can measure the service level. So service level means the level of customer service based on the inventory. So there is a two-way to measure this service level. One is cycle service level and another is a fill rate. So cycle service level means the proportion of order cycle in which no stock out occur. Okay, so which means we are talking about the overall the total orders came, and on those total orders, how many times against those orders we are no stockouts and how many times we are stockouts. So how we can calculate, we will talk about in a minute. And then second one is that is based on the fill rate. So basically based on the proportion of the customer demand that is satisfied from the on hand inventory on hand. So that means in a fill rate we are talking about how much quantity we have fulfilled the demand of the customer. So here we are talking about the individual SKU quantity perspective. Here we are talking about the order cycle, or you can say how many number of orders we are no stockouts. Okay, So let's take the example in order to clearly get the understanding regarding what is a cycle service level or how we can calculate it as well as the fill rate. So suppose if we are saying there is a 12 order came to our company. Okay, so the in a first order we got that we have to fill the demand of 23 unit. In a second order that is 18 unit. In a third order we have the demand was 31 up to so on, right? So this is indicating the number of item out of stock. So 0 is indicating that the demand came 23 unit, and 0 means we fulfill all the demand. Okay. Same is the case over here. 18 demand came out and we fill out all the demand because we have the inventory of that SKUs. But in a third part, it is indicating that the demand is 31, but we would able to meet the 25 units, so 6 are left. So that means, so this is first stock out occur and the number of units stock out is 6, so up to 12, right? So the total demand, if I am saying that against these 12 order cycles were 300 and 41 units were the stockouts. So based on this data, how we can calculate the cycle service level, which is also known as beta service level, and how we can calculate the fill rate, which is also known as alpha service level. So as far as the beta service level or the cycle service level, which is based on the order cycle in which no stock out occur. So how many order cycle? That is 12. So out of 12, how many time when there is no stock out, when there is zeros are items out of stocks. Okay, so we can count at it that out of 12 there is a 8 total order cycles when there is no stock out occur. Okay, so that means 8 divided by 12, 67%. So that means we can say that whenever there is a order came, so 67% chances that there will be no stock out in that order cycle or the replenishment cycle. So whereas how we can calculate the fill rate, that is how much the total demand against these order cycles, that was the total unit which was 300. Okay, how many units were the stock out? That is of 41. So 300 minus 41, this is indicating 259. So out of 300, so 259 units we delivered on time. Okay, or fulfill the demand of those customers. So how we can find out the fill rate? That is going to be 259 divided by 300, which is indicating 86%. So that means 86% of the units of the demand, or 86% we have fulfilled the demand. The rest 14% was the stock out, right? Now, as I mentioned earlier, that in order to find out the stochastic inventory model, okay, regarding the continuous review policy, when we are monitoring the quantity level of every SKUs, so either we can find out based on the empirical data, which means based on the historical data which we have calculated, or either we can calculate based on the statistical distribution. So in this part, I am going to cover the empirical distribution part. So suppose I am considering right now in order to calculate the safety stock based on empirical data, means like this is the data set. So I am considering the example right now, the lead time is constant, but the demand is in a variable form. So as you can see from this data, it is indicating a manufacturer weekly demand for the item with the lead time is constant, which is 1 week. So they have given us the item cost, or which means the product cost. So it is also indicating the inventory carrying rate, which is 20%. So based on this, we can easily calculate carrying cost per unit, which is going to be zero point 0.2, which is interest rate. Okay, inventory rate, which is 20% multiplied by the product cost, which is 50. So based on that, we can calculate the carrying cost. Okay, further it is indicating determine the safety stock level as well as the carrying cost if the manufacturer desire the service level 85% as well as 95%. So in order to calculate this safety stock, what we will do, so we have collected the historical data, which is a weekly demand, and when we have collected the data, we found that two times the weekly demand was between 1 to 50. So 4 times the weekly demand was between 50 to 100. 7 times the weekly demand was 100 to 150. Up to there is a 3 times when the weekly demand was 450 to 500, right? So using this data, okay, we have written down again based on the frequency. So based on the frequency, we have calculated the cumulative frequency. So how we can calculate the first frequency would be written as it is. So this 2 plus 4 is going to be 6. 6 plus 7 is going to be 13. 13 plus 8 is going to be 21, and so on. Okay. And then based on this cumulative frequency, we can calculate the cumulative probability. So 2 divided by sum of frequency, which is 60, then 6 divided by 60, then 13 divided by 60, then 21 divided by 60. So we are getting the cumulative probability, right? Now, what we will do, we are going to draw this weekly demand as well as the cumulative percentage. Okay, so this is the quantity, okay, which is basically the weekly demand, and this is basically the cumulative probability, or you can say the service level from 0 to 100%, which is 1. And how we are going to do the weekly demand, it is always from the upper class value, which means 50 to 500. Okay, so we have on this one, and then this line is basically indicating the cumulative probability, which means against 50 we have the cumulative probability 3%, against 100 we have the cumulative probability 10%, against 150 we have the cumulative probability 22%. So these dots are indicating those percentages, right? So the question was, we would like to find out the safety stock against the service level of 85% first. So what we will do, we will find out the percentile against 85. So what's the percentile? So it is indicating against what value at least 85% of the customer's demand we will fulfill. Okay. So what we will do in order to find out the percentile of 85, so against this cumulative probability, which is 85 percentage over here, it's a service level. And if we draw this dotted line and go down way, so it is indicating the 390 over here approximately. Okay, so that means, so at least 85% customer demand is going to be fulfilled, okay, when the quantity is going to be 390. Okay, same is the case, we can find out the percentile against the 95%. So this is 95%, and then if we draw this one, which is 450. So in order to calculate the safety stock, what we will do, we will subtract this value from the average demand. And how we can calculate the average demand? That is going to be against the 50th percentile, which is the average point, which is 50th, which is 250. So 390 minus 250 is going to be the safety stock against 85% service level. Okay, whereas 450 minus 250, that is going to be 200 against the 95% percentage of the service level. So that means if you would like to satisfy the 95% of your customers, okay, then your safety stock in this particular data case, so it should be 200. If you would like that the service level should be 85%, so then the safety stock should be 140. And then based on the data, we can calculate the carrying cost. Okay, so 140 multiplied by carrying cost per unit, so this is carrying cost per unit multiplied by the safety stock, same is the case against the 95%. Now let's discuss the second scenario when the lead time is in a variable form. Now we are assuming that the demand is constant, but the lead time is in a variable form. So the same concept we will use. So as you can see over here, so there is a 2 time when the lead time was 1 day. There is a 3 times when the lead time was a 2 days. So basically we have collected the historical data, and based on that data, we would like that the service level should be 85%. Okay, okay, now similar approach we are going to adopt. So this is the lead time, we have the frequency, we are calculating the cumulative frequency, and then based on that we are calculating the cumulative probability. And then we are drawing the graph. So once again, on x-axis we will take the lead times, on y-axis we will take the cumulative probability, which is indicating the service level, and then we are going to, which is from 0 to 1, and then using this line we can draw the cumulative probability, right? So against the 85%, so what's the lead time? That is the 7 days. Okay, against 85%, we have 7 days lead time. And then in order to calculate the safety stock, so the average is 4.7 days. So that means 7 minus 4 point this one, this is indicating the 2.3 days. So that means the safety stock should be maintained to reach the service level 85% should be equal to 2.3 days inventory. So I hope you got the idea how we can calculate the safety stock using the empirical or the historical data, and what is the safety stock and what are the different service level measures. So thank you so much. See you in the next video.